You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Rhyme, DJ Starwatcher. How are you, Bernie?
Yes, hi Sarah, very good, thank you.
Bernie is our professor of the astronomy lab at USM and our local protector of the night skies. Reach out to us at WMPG Scientifically Speaking at gmail.com or on Twitter at WMPG SciSpeak. And if you missed this show or any of your other favorite shows, you can head over to WMPG.org to find the last 5 weeks of archives. Bernie, could you let our listeners know what is up in the night sky for this coming week?
Okay, certainly good, I'll do that. Okay, so today will be Friday, August 27th. So we're going to have a waning gibbous moon. It was full on the 22nd, and it'll be last quarter on the 30th. So it's going to be rising a little bit around midnight or so, a little bit before. And then planet-wise, Jupiter and Saturn are still very well placed. They were at opposition earlier this month, actually, so they're coming up before sunrise now. So as soon as it gets dark enough, you can see them in the east. And then you can still see Venus. It's pretty low, but it's pretty bright. That's setting in the west shortly after sunset. You can see those for the planets. Maybe still see a few leftover meteors. I saw a few Perseids when I was up early a little while ago, but most people I know didn't see a lot of the Perseids. So yeah, so just getting towards, late summer, and basically keep watching Jupiter and Saturn and Venus. That's pretty much all in the evening sky. The sunrise will be at 6 in the morning, and then the sun sets about 7:30. So the days are still well over 12 hours long because they won't be even until September 22nd. So we're less than a month now till fall starts.
Don't remind us, but I guess
Yeah.
fall brings a lot of great things.
Yeah.
Although, speaking of the meteors, Bernie,
hmm
um, I know how, or with any of the planets, I know how you're like, go look up for them. But I want to say this summer has not been a great
Mm.
time, or in terms of
Yeah.
conditions for night sky viewing.
Yeah, I know a lot of the things like the conjunctions of Mars and Venus and a lot of things that were happening I didn't even get to see, nor people in my club. And a lot of things we had planned at the club really wasn't clear enough.
Right.
Yeah.
And, July, at least here in southern Maine, we
Mhm.
had 19 days of rain.
Oh, okay.
19 out of the
Yeah.
31 days were rain.
Yeah.
And you've been living here for how long, Bernie?
Oh, in Maine?
Yeah.
Oh, since I moved back from New Orleans in 1981.
And I mean, I haven't been here that long, but this was
hmm
the wettest summer that I've experienced so
hmm
far. Do you
Yeah.
feel like if you just think back over the years, do you feel
Mhm.
like this is normal?
Well, it varies a lot. I mean, overall, I know the seasons are getting longer, like for crops and things. And we had a lot of droughts. I mean, not as bad as some nearby states even, but so at least we're not officially in the drought anymore. But yeah, overall, the changes are more extreme because that's kind of what we'll
Mm.
be talking about today.
Yeah.
Yeah.
So I'm going to pause and just
hmm
say thank you, Bernie, for the Night Sky
hmm
Report.
hmm
And definitely check out the Portland Press Herald for the monthly What's Up in the Night Sky that Bernie does. And so that little segue was a little hint about what we are going to talk about for today's show. And maybe we can't really look at one summer and be like, oh, it's getting worse one summer, right? But it is all part of a trend. And so that's why I asked, like, you've been here for a couple decades, I guess.
Yeah, 40
And
years.
yeah,
Yeah.
and
Yeah.
so you
hmm
probably have a sense of some of the changes that you've witnessed over time.
hmm
It's a little harder to just look at, even 4 years, 3 years, and notice these things. But we do, I mean, over the years, it does seem like we do hear more and more disasters and more precipitation. Obviously, this year we heard about all the fires and a lot of drought. And so recently, actually, when was it released? When was this report released?
August 6th, to be precise.
August 6th.
Yeah.
So known as the International Panel on Climate Change. The IPCC was founded in 1988 and is a conglomerate of 195 countries. And the scientists from all of these different countries basically put together comprehensive assessments and reports on special topics, methodologies, etc. And they kind of highlight the latest knowledge on research that has already been done, evidence on climate change caused specifically by human activity. And so that is what today's show is about. We wanted to talk about the IPCC, do kind of a little bit of a summary of some of the highlights of the 4,000 page report,
Yeah.
and talk a little bit about how we know certain changes in the climate are human driven. And then we've got some information, some really interesting information on the computers and the modeling that the scientists are able to employ to make these kind of extrapolations and interpretations of what we can expect if we don't do anything, if we don't take action. And then finally, we'll leave you with some suggestions on what we could possibly do as individuals. But one of our prior guests on the show, Keith Launchbury, likes to say is that it really isn't us. It is industry, and it's what policy does and how do we drive change on a greater scale. Back to the IPCC. This is the sixth assessment since
1990.
1990. They do these assessments every 3 years.
Well, roughly, I mean, it depends. I mean, it's the 54th session. I mean, they meet quite a bit, but these huge reports, they don't put out quite as often. But this is the sixth report. So maybe every 4 years or whatever, yeah.
And so this report is, as we said, it was about 4,000 pages. Well, 3,900 and something pages. It is a conglomeration, a summary of all this research done by all the scientists who are climate scientists or who look at changes in the climate caused by humans. There's not really a lot of new stuff from the report, right? It's all stuff that we kind of already knew. But there were a couple things that maybe, Bernie, you wanted to highlight.
Mm-hmm. Mm-hmm. One of the questions under the frequently asked questions that did talk about the Gulf Stream potentially shutting down or slowing down, which would not be good. So what was interesting, what I learned about it, is that it actually has two different components. It's not just, some water moving through the Atlantic there. It has the Atlantic meridional overturning circulation. And so that's like the vertical of the y-axis of what's happening in the Gulf Stream. And then the x-axis of the horizontal, which is 5 times the strength, is the North Atlantic subtropical gyre. So that's actually composed a lot with the wind driving that. And that part is actually slowing down a little bit, but it's not shutting down. It's been pretty stable for 8,000 years. So another thing that was interesting is how much water is being transported. Of course, there's lots of other currents all through all the oceans of the world, but we're most interested in the Gulf Stream because it's right off the coast of Maine here. So 30 billion kilograms of water every second are being transported northward by this Gulf Stream. So now I see it better in 3 dimensionals with the two components and how they work together and how important all that is.
Yeah. Nice. Yeah. And the other thing too is that there's a lot of research that says that the permafrost thaw in Siberia also is kind of creating this ticking bomb of methane. The IPCC report suggests that maybe that's not as dire as we think it is. It may not happen as soon as we originally thought. So some positive things to look forward to.
Yeah, that's good. Because actually methane is a more powerful
It is.
climate change gas than CO2, and even water vapor is. So water vapor is important too. I've seen these maps. Sometimes the weatherman will show them the water vapor over like the tropical seas, and even in Maine, obviously, it wouldn't be as extreme. Though, like the water it'll be like 90 degrees above the water, and just the whole way the water vapor moves, you can kind of get an image of that or see it. And that is a very strong greenhouse gas also. Now this whole process of climate change is understood a lot better, and the main reason for that is we have far more detailed and faster computers and better modeling techniques and inputs to get better outputs to really see what's happening. Far more satellites. I mean, they just launched some new satellites even this year that will look further deeper into the ocean and model the air. So we have so much more information that obviously, will tell us more. So the computer part was really interesting. So when they started in 1990, which was like, almost the dinosaur days for computers, they had the fastest computer in the world was the Cray 2. You might have remember Cray. So it could do 1.9 gigaflops. So flop is just the abbreviation for floating point operations per second. So basically that many calculations per second. So 1.9 giga, that's 1.9 billion. So yeah, so you may think that's a lot and that's pretty fast. And, I guess they put a decent report together back then in 1990 with that kind of a computer. If they even use that, they may not even have used the Cray for the report. But now, so they started moving up from then. So the next step would be teraflops, which is a trillion operations per second. So by the year 2000, they could do a trillion per second. And then the next step, if you know your metric system of prefixes and everything. So 2008, they could do petaflops. So that's a quadrillion. So by 2008, they could do that. And now they're working on the next step, which would be exaflop, which would be a quintillion or 10 to the 18th operations per second. So right now, the fastest supercomputer can do 442 petaflops, so 442 floating point operations or calculations per second, and it happened to be in Japan. So us, China, and Japan are always trading for the fastest computer in the world, and I'm sure they're not using that for this particular modeling. But that's now the capability. So it's almost a half, it's 442 petaflops per second. Wow. So it more than doubles. So the computers are just, amazingly more, can just do so many more calculations, and then we have the modeling techniques. So that's why we know so much more and how we understand the climate better because of that.
We are seeing increasingly variable changes that threaten our global food supply, which will be increasingly vicarious. We're seeing more extremely hot weather, more frequent and intense precipitation, and extreme droughts. And I think these computers that Bernie is talking about allow us to actually look into the future of, like we said, what will happen if we don't do anything about this. And I don't know, Bernie, do you think we're doing enough?
No, we're not. We're not doing enough individually or industry, like he said, or policy-wise or anything. No, we can always do more and demand that the people representing us are doing more too.
Yeah.
Yeah.
And so one of the things that the report actually talks about in terms of projections is that across kind of warming levels. So as the temperature increases, we kind of just assume that it will all be uniformly increased. What they find with their computers and their modeling is that land areas will warm more than oceans, which that makes sense. But the Arctic and Antarctica will warm way more than the tropics. Yeah. So the tropics will actually be more stable than the poles, which is, of course, important because now all of our ice sheets are melting. They'll release more greenhouse gases, and our sea levels will rise. Precipitation is also projected to increase over high latitudes and equatorial, kind of Pacific, and parts of the monsoon regions like Indian subcontinent, etc. But they will actually decrease over parts of the subtropics and in some areas of the tropics. And so that could lead to more flooding. For example, Maine, we will also see a lot more precipitation. It almost feels like, this past summer has just been, it's like a look into the future in some ways. And then across warming levels, we will also see changes in soil moisture. And that's also following changes in precipitation, but, also due to kind of just evaporation or transpiration, I guess, if you will. And so as some of our tropical areas become warm, we'll lose more moisture in the soil, and maybe crops won't grow as well. And so if we see kind of more extreme variations, for example, the Indian subcontinent, that was a specific area that has been looked at, they might see more kind of droughts. They might see more, more, some years with way more water, and then, that kind of cycling is just not really great for crops and agriculture in general. One of the things that the report also mentions as you read through it is this use of the language choices, I guess, that the scientists have used in terms of writing it. They use a lot of words like unequivocally. They use a lot of terms like virtually, in like you can't even argue against it. And so, for example, the report does confirm that observed increases in greenhouse gas concentrations since 1750 are unequivocally caused by human activities. And they can measure that in the concentrations in increases in concentrations in the atmosphere. And for example, we have reached annual averages of 410 parts per million of carbon dioxide. And, that has changed over the decades. Each of the last 4 decades has been successively warmer than any decade preceding since 1850. Global surface temperature in the first 2 decades of the 21st century, meaning 2001 to 2020, was 0.99 Celsius, so almost 1 Celsius higher than in between 1850 and 1900. And then our global surface temperature was 1.09 degrees Celsius higher than 2011 to 2020. So that's kind of an increase just in the last decade.
Yeah.
Global mean sea level also increased about 0.2 meters between 1901 and 2018. And then between 1901 and 1971, global sea level rise was 1.3 millimeters a year. So the report does state that human influence was very likely the main driver of these increases since at least 1971. What other highlights did you kind of glean from the report?
Well, since you mentioned sea level rise, of course, that's a big thing. So they're predicting by 2050 it'll be 25 centimeters. So the rate of the rise is going up. That's a whole foot.
Yeah.
And that's less than 30 years from now. So yeah, a few millimeters per year isn't that much, but the next 30 years, 25 centimeters.
Yeah.
That's way more. And actually the way to show that is that the spring tide, so twice a month we have higher tide because of the moon alignment. A lot of cities like Miami, they're already getting street flooding twice a month just from the higher tides. And I went to a thing in Portland a few years ago at one of the king tides or spring tides, they call them either way. And it was right by the pier there and the where the Eastern Prom Trail starts, and that whole little park was flooded, and people were there, and they even had actors kind of showing, how far up that would go now, and just in a few years, it's going to be, another several feet further up within that park area and so on. That just gives you a sense, even in Portland, we're not Miami, we're not like right at sea level, and we're getting the same issue. So it was that. And then other interesting things. One was like the Earth energy budget, like the bigger picture of the cycles and how that works. So in general, of course, the sun provides all the energy. So 1/3 of it is reflected back to space right away. That's called the albedo. Actually, I remember doing a report in college on that. So that could also be called the reflectivity coefficient. So 1/3 would be 0.3. I mean, 0 would be totally black, absorbing everything, and 1 would be white, reflecting everything. So the overall Earth is 0.3. However, the oceans without clouds, they're much closer to 0. They're like 0.1 because they absorb like 90% of everything. So that would be bad, of course, if we had no clouds to reflect any of it back. But the Earth as a whole, like 75% of it is usually covered by clouds anyway. So that has a lot to do with it. And of course, the greenhouse effect part is because all this energy comes in, and if not enough of it gets reflected back, it gets re-radiated, which if you put out the greenhouse you want, because you want to raise some plants in winter, but if you don't want the entire Earth to warm up and not be able to shed that extra energy back from the sun like it's been doing by itself for billions of years until we stepped in the last 100 years or so to change that whole balance. So that's like the bigger picture of how that works. So 1/3 of it's reflected back to space. And then, of course, things are getting more extreme, too. If you have more heat, the hurricanes, I mean, we have one heading for Maine right now. We're recording this a little bit early, but we don't know how severe it's going to be up here in Maine. Hopefully not too bad. And then the droughts. And the fires, I mean, several nights this summer we couldn't do some astronomy, even though it was perfectly clear. We had smoke all the way from
Hmm.
Oregon. The moon was kind of pink, even though it was right overhead. It was almost like it was being eclipsed. It was very strange. So in Maine, we don't see as much of it, but we should be aware of what's going on globally and
Hmm.
what we can do about it too, of course. Yeah.
Yeah, and speaking of Maine, we're actually relatively safer from flooding just
Mhm.
because we don't have a lot of beach. Um, like, not all of our coastline is beach like Florida is. And
Yeah.
so, what that means is our rocky coast actually helps shield us from really strong storms in some ways. Uh, the areas that you were talking about, Bernie, in Portland,
Mhm.
those are actually the most vulnerable areas because those are actually filled land. It's not actual
Oh, I didn't know.
land.
Yeah.
Yeah. And so
Mhm.
all kind of Bayside area, and then kind of other parts of Back Cove and
Mhm.
yeah, I think those are the kind of key areas.
Mhm.
Those that's all filled land. And actually it's interesting, you can see a map of the peninsula, what it looked like in, I would say, maybe the 1800s or so, and
Mhm.
you can see basically all the regions that were filled. It's hard to tell
Mhm.
now, but
Sure.
you know, if you live in those areas, you can
Mhm.
expect way more flooding. And I believe the Gulf of Maine Institute has a really great GIS map, an
Mhm.
interactive map that shows kind of where would be flooded if we reach, say, 10 meters of sea level rise. And that was just kind of the upper extreme of
Yeah.
their prediction model. And yeah, I think where I'm living is relatively safe, but some of those other areas you could be pretty much underwater. So, anyways,
Yeah.
just a thought.
Yes.
So, one question that we wanted to also answer was, how do we even know that climate change is driven by human activity? Um, it, one, this is an argument that is, the climate change deniers, versus there are even some scientists who kind of say no, like that's not really true. And in reality, like when we do look at climate and kind of geology and weather patterns over centuries, over eons, we do see cycles of warm and cold climates. That's why we have ice age and why we have warm spells. And there are things that the earth that do contribute to the warming or the cooling of the planet. CO2 is, obviously a greenhouse gas, and it is the one that gets the most attention. And it is the heat trapping gas in our atmosphere that is responsible for most of the warming over the past several decades. Human activities such as manufacturing and, burning of gas, oil, coal, etc., that releases a great deal of carbon dioxide. And I would say the start of all that was kind of the Industrial Revolution, which is why we see a lot of, how do we measure human activity and its impact on climate? And that's kind of where we start looking at it. It was about 1800 or so. And so, as I mentioned before, our current levels are about 410 parts per million. 150 years ago, which is pre-industrial era, the concentration of that was 280 parts per million of CO2. And so that's almost double.
Yep.
But how do we actually know it? So we had Ned Shenton, Grateful Ned, if you remember him. He was on one of the Greenland expeditions to get ice cores, and carbon dioxide is actually can be measured from ice cores as snow melt and it refreezes. And so you can actually drill these ice cores, like I think what did they drill, like a mile long or something, a
Yeah.
very very long ice core. And so that's how they can actually measure CO2 in the atmosphere over the last 100,000, whatever
Yeah, it was
time
hundreds
frame.
of thousands. I don't think it was
Yeah.
into millions.
Yeah.
Yeah.
And so as the concentration of CO2 goes up, the earth will also warm up. And since the 1950s, we have undergone unprecedented warming. As Bernie was talking about those computer models, the stronger and more powerful they are, the more precise we can get because we can kind of drill down further, more and more and more. You know your calculus, you know your, you know your Taylor series. All of that helps us get to a more accurate answer. And so CO2 produced from fossil fuels carries a very unique signature that differentiates it from CO2 produced from other sources. And so we can tell, for example, CO2 produced by, I don't know, volcanic explosion or eruption, sorry. And so these models can actually, or these computers can actually model the sum of the CO2 released by natural processes, which is solar, volcanic, and other just general natural variability. Maybe more animals are farting. I don't know. And then we can also see the change and the deviation by what we actually are measuring now. And so basically you can take the difference of what you expect from the sum of natural processes and then what we actually are seeing, let's say in the last 50 years or so. And that difference is how we identify that this huge change that we see is caused by human activities. And so that's how we kind of can measure climate change contributed by human activity.
Yeah. Plus, I mean, obviously, just in the last 100 years, when it went from 280 to 410, there weren't a lot of huge volcanic eruptions that would add too much. You know, we had a few little minor ones, Mount St. Helens and so on. But yeah, so, and then the sun, I mean, the sun has an 11-year cycle. That was the other variability, but that's pretty much worked in. So that's not doing that. So yeah, it's pretty obvious now that it's human created.
Yeah. And, you know, like we mentioned, there's very few places on this earth where there is little agreement that temperatures have been increasing, that there have been an observed change in hot extremes. And the report does kind of have really great graphical representations of this. Same with precipitation. There's been much more bouts of heavy precipitation across the world. And also increased drought, agricultural and ecological drought. So, Bertie, what can our listeners do? Like besides recycling, you know, we're trying really hard to recycle and reduce our single-use plastics, but then Jeff Bezos is having a fun trip up to, you know, up to the edge of space. What can we do?
Well, I mean, I think we have to do things like try to move from fossil fuels to solar and alternative energy sources. Of course, you know, we have to write our congresspeople and senators and so on to, you know, watch what's going on and what would be best for everyone. And, you know, just to be more aware of it too. I mean, one big thing with the climate change is also the pollution that's tied in with it. I mean, 4 million people a year die just from bad air and from air pollution. So there's a lot of other incentives. Like we could divest from fossil fuels. Some countries, some cities, some companies have done that. Some churches and institutions and a lot of universities have done that, and not, you know, invest more money into something that's bad for everybody.
Right.
So, and just to be more aware of it and to do something, divest off of fossil coal. We know coal is bad, but oil, and there's still a big thing on oil, so we can use less of that too.
Yeah. And inform yourselves. I mean, all of this is not new, right? Investing in clean energy economies, transforming transportation, reorienting our food system. All of this is already happening, but it's really good to inform yourself as well. You don't have to read all 4,000 pages, but it is really important for us to try and help battle disinformation. Like, we don't need to criminalize our neighbors and friends for using single-use plastic here and there. We're, you know, trying as hard as we can. But at the end of the day, we need to reach back out to these companies that are making terrible decisions. It is not supposed to be our responsibility as consumers to decide how everything is disposed of, because we don't do a very good job of it. And these companies need to start taking responsibility in how they decide to package. They're the ones who can make the biggest impact, because me saving one plastic bag is not going to do anything if they're sending, millions of them across the world. So anyways, we will continue to try and bring more light to this to help keep you guys informed, and hopefully we can continue to inspire you and all your friends to fight the good fight as well. You've been listening to Scientifically Speaking here on WMPG 90.9 Gorham, Portland. Stay tuned for Disco Jams with Jam Lewis. And from your favorite nerds, remember to vaccinate, mitigate, and we can all congregate.